Today we're going to discuss the topic of uh, equilibrium, force laws, and force system in biomechanics. I'm Abdul Tawfiq, Assistant Professor, SMS College of Physiotherapy. Shall we start? So, equilibrium and law of inertia. So, what is meant by equilibrium? A law of acceleration, joint distraction, friction in a linear system that may or may not be back to its own place. It's called equilibrium. So the inertia, the law of inertia may be influenced as law of acceleration, joint distraction, friction in a linear system, the concurrent force system, and parallel force system. So, what is meant by concurrent force? Compositions of muscles, action in a line, and diversion of anatomical pulley. That means jumping activities. The parallel force system and lever system are first, second, and third class levers, torques, and mechanical advantage that may or may not be opposed to and activating the system. So to empathize the topic, equilibrium and law of inertia are law of inertia means Newton's first law. An object remains at rest or in uniform motion unless acted upon by a net unbalanced force. It is called law of inertia. So equilibrium, a state in which net external force on an object sum to zero, no accelerations has been occurred. So what are the conditions for the equilibrium are static or dynamic. The two main conditions may be occurred in the object. So F is equal to 0, sigma F is equal to 0, net of force is equal to 0, M is equal to 0, then sigma M is equal to 0. The types of equilibrium are stable, unstable, and neutral equilibrium. So equilibrium object, a free body, isolated, the object drawn all forces, weight is applied, and the reaction friction has been occurred. So an isolated object, the body is occurring towards downwards, opposing the anti-gravity pull, and the gravitational force is also inversively acting to the object. Sum of the force in all directions is equal to 0. Sum of the torque about the pivots are 0. Example, beam with supports and loads a selective pivot to simplify the torque and equations. The reaction force at suppose. So the law of acceleration and the object in a motion. Law of acceleration, Newton's second law. Acceleration is equal to direction of force. So acceleration is the direction as equal to the direction of net force. So where we give the acceleration, the force are the same plane when we have heavier destroyed objects. The heavier mass is equal to smaller acceleration may for some forces and smaller mass, heavier acceleration may also give same force and same effect. So applications of pushing, pulling, straight and stopping momentum may occur and may give the same results to the objects. So joint distraction in a linear force system and force frictions. So linear force system or force are in a same plane along the same path. So joint distractions are a force that pulls apart of the joint surface act as perpendicular to the joint surface. Opposite force acting on adjacent bone segments. Joint reaction force and compression force when segment pushed together. So friction force, a resting shear force between contacting surface, static friction versus kinetic frictions. So friction means the socks that may lay on a mat. We may diagonally walk, and the walking surface of the inner sole and the mat sole has been rubbing, the rubbing surface of friction. So there will be a static friction and kinetic friction. The towards the static friction continuously walk in the same act as the same place. They may change into kinetic frictions.